All right, so we're going to talk about multiplying and dividing rational expressions today. And when you are dealing with rational expressions in any format, whether you're just simplifying, multiplying, dividing, adding and subtracting, which will be in the next lesson, does not matter. It takes a lot of patience. They are very time consuming, but it just takes a lot of patience. So you're going to have to slow down and make sure that you do everything correctly. So this is a situation of, in the first box, we are getting our rules for multiplying. So when you multiply, of course, denominators cannot be 0. So P times R, multiply across the numerator, multiply across the denominator. But there is a catch. So the rules for multiplying rational expressions, you factor numerator and denominator. So factor everything that can be factored. Simplify ratios of common factors to 1, or if you run across opposites, they simplify, remember, to -1. So make sure that it's either a 1 or a -1 when you cancel. And then you multiply the remaining factors in the numerator and the denominator together. So the first one we've actually already done. We did this way back in chapter 5. So what we can do is multiply straight across. So that's going to be 40x squared y to the third. Across the bottom, I get 210 x to the 6th, y to the 5th. The zeros will cancel. You cannot simplify 4 over 21. When you subtract x squared minus 6x, you get x to the -4. So that drops to the denominator and becomes positive. When you subtract your y's, 3 minus 5, you get y to the -2. So that also drops to the denominator and becomes positive. So there would be your final answer for number 1. You do not have to factor anything because those are all monomial terms. Both numerators, both denominators are monomials. Now, if you look at example 2, I have a binomial and a binomial. So basically anything that is binomial bigger, you have to try and factor. So the factors of the numerator would be 4, a plus 2. I can't factor a to the third because it's a monomial. I cannot factor 3a, it's a monomial, and I can factor out the 6, a plus 2. Now I can cross cancel. I can cancel a plus 2 with a plus 2. When I multiply what's left, that gives me 12a over 6a to the third. I'm multiplying all monomials because that's all I have left. Then I can reduce that. 6 goes into 12, so I have a 2 on the top. And then when I subtract my a's, that's 1 minus 3, which gives me a to the -2, so my a squared ends up in the denominator. So that would be my final answer for number 2. All right. Number 3. Anything that is binomial or bigger has to be factored. So this is a difference of squares, so I'm going to factor that as 3 plus 2a and 3 minus 2a. Remember, difference of squares factor to conjugates. This, I take out the greatest common factor, 2, so that gives me a 2a minus 3. Monomials, I cannot factor, so 4a stays. And then when I factor that trinomial, I get 2a plus 3 and a plus 1. Now, I can cancel 2a plus 3 with 3 plus 2a. They are exactly the same, so I get a 1. I can cancel 3 minus 2a with 2a minus 3 because they are opposites. So when I cancel that, I get -1. So across the top, I have 1 times -1 times 4a, which is -4a. Across the bottom, I have 2 and a plus 1. So 2 times a plus 1. Now, since I have a monomial in my numerator and a monomial in my denominator, I can reduce both of those numbers by 2. So that becomes a 1, and that becomes a negative 2a. So I end up with negative 2a over a plus 1 in my denominator. So lots of factoring, lots of canceling. We had same, which cancels to negative 1 or to positive 1, and then we had opposites, which canceled to negative 1. So look for both of those, same cancellations or opposite cancellations. Now, in number 4, we have a lot of different factoring to do. Here, when I factor that, I get 7b squared minus 1, and that factors again. So I get 7 conjugates b plus 1, b minus 1, because that is a difference of squares. Denominator, difference of squares, b plus 3, b minus 3. Second numerator, I don't need to factor it. I just write down b plus 3 twice. That's what it means to square it. And then I have to factor, so that's 14 b squared minus 1. I'm sorry, I take that back. I did not factor that correctly. I did not take out my common factor b. So I take out a 14b, which leaves me with b minus 1. So my denominator for that second fraction, so I cancel what they have in common. A b minus 1 cancels. That's a 1 to 1, so that's positive 1. B plus 3 cancels b plus 3. Those are same, so they cancel to positive 1. So across the top, I have 7b plus 1 times b plus 3. On the bottom, I have 14b and b minus 3. Now, the last thing I need to do is look here. Can I reduce those monomials? And I can. 7 goes into 7 once, and that would turn into a 2b. So my final answer would be b plus 1, b plus 3 over 2b times b minus 3. Now, division is a glorified multiplication problem because in order to divide fractions, you have to change it to a multiplication problem. So division has one additional step. The first thing we do is we multiply by the reciprocal. We change it from a division problem to a multiplication problem, and then we follow all the rules for multiplying rational expressions together. So in this particular problem, we are going to rewrite this as a multiplication problem. So I'm going to take the second fraction and I'm going to flip it. So 5b to the 5th over a squared b squared. Now when I multiply straight across the top, I get 20a to the 3rd b to the 5th. When I multiply across the bottom, I get 10a to the 4th b to the 3rd. The zeros cancel, so I'm left with 2 on top. When I subtract my exponents, 3 minus 4, that gives me a to the negative 1, so that drops to the bottom. When I subtract my exponents, 5 minus 3, that gives me b squared, so it stays in the numerator. So my answer to this problem number 5 is 2b squared over a. Now, number 6, the way they have written it, it's a funky division problem because it says the numerator divided, that's my division symbol, by the denominator. So technically, that is 14cd to the 4th over 5c squared divided by 7d to the 3rd over 20c squared d. Now, that's what that problem says, one fraction divided by a second fraction. Now I'm going to flip and multiply. So I have 14c to the 3rd, d to the 4th over 5c squared times 20c squared d over 7d to the 3rd. So I multiply straight across. So 14 times 20 gives me 280. So 280 c to the 5th, d to the 5th, divided by 35, 5 times 7, c squared d to the third. Now, 280 divided by 35 is just 8. When I subtract my exponents, 5 minus 2, c to the third, that stays on the top. When I subtract my exponents for d, that's 5 minus 3, which is d squared, so it stays on the top, and the numerator or denominator becomes a 1. So since everything canceled out of the numerator or denominator, you do not have to put a denominator of 1. You just leave it without a denominator. It's understood to be there. You just don't have to write it. So 17 and 18 involve binomials or bigger. So we are going to have to factor anything and everything binomial bigger that we can. So the first numerator factor out the 12, that's x minus 2. Second, or the denominator, factors to x minus 2, x minus 2. I'm going to flip and multiply, so I've got to flip this one, x plus 2 over 4x. Now, the x minus 2's will cancel. That becomes a 1. I cannot cancel anything else, so I end up with 12 over x plus 2. And I have 4x over or times x minus 2. Now, the x plus 2 and the x minus 2 cannot cancel because they are not exactly the same, but I can reduce the 4 and the 12. So that becomes a 1 and that becomes a 3. So my final answer would be 3 times x plus 2 and x times x minus 2 on the bottom. So that would be my final answer for number 7. For number 8, I have lots of things that need to be factored. The first numerator, it's take out a 3. That leaves me with m squared minus 9. That's a difference of squares, so I end up with 3 times the conjugates, m plus 3, m minus 3. I'm going to factor my denominator. That's going to be m minus 3 and m plus 1 when you factor that denominator. Now, when I flip, this is now my numerator, because remember, you have to flip it. So m squared plus 2m plus 1 is now on top, and 6m plus 18 is on the bottom. So I'm going to factor that denominator first, because all I have to do is take out the 6, and I get m plus 3. The top, when I factor it, I get m plus 1 twice. So I can cancel the plus 3. I can cancel one of the plus m's. I can cancel this m minus 3 with this binomial m minus 3. So all that I'm left with is 3 times m plus 1 on the top, 3 and this m plus 1, and the only thing left on the bottom is 6. Now, these are monomials, so I can reduce that to m plus 1 over 2. 3 goes into 3 once, it goes into 6 twice, so that reduces down to a 2 as your denominator. All right, so in this problem, we are multiplying. So I'm going to put that over 1. You do not flip when you are multiplying. You only flip when you are dividing. So I cannot factor this, so 2m plus 1. I can factor this into 2m minus 1 and m plus 6. And I'm going to multiply that by m plus 6 over 1. I can cancel the m plus 6, so my final answer would be 2m plus 1 over 2m minus 1. Final answer for that one. All right, over here I am going to have to flip and multiply, so I'm going to factor first. That would give me 4y plus 3 and y minus 1. I'm going to factor here, take out the 3. That leaves me with a y minus 1. Now, remember, I have to flip that, so that gives me 1 over 4y plus 3. I cannot factor either one of those. So the 4y plus 3 cancels, the y minus 1 cancels, and I'm left with 1 in my numerator and 3 in my denominator. I have a lot of stuff going on here. Number 11, I am going to take this one and flip it. I have to factor my numerator, so that would be a plus 6a minus 3. I'm going to factor my denominator, which would be a plus 5 and a plus 8. I'm going to multiply it by a plus 5 over a minus 3. Remember, I had to flip this fraction so I could multiply. Cancel my a minus 3's. My a plus 5's will cancel. So I'm left with a over 6 over a plus 5. Now, you cannot cancel those a's because, I'm sorry, I said the right number and then I wrote down the wrong thing. I apologize. That should be an 8. I said 5 and 8, and then I wrote down 5 and 5. So let's back up here. That goes away. And that one cancels. Okay. I cannot cancel these a's because they are part of a binomial. So it's all of the binomial or none of the binomial that gets canceled. All right. In this problem, we have 4 more terms. So we are going to factor by grouping. So I'm going to group the first two together, ax minus a. And then I will group the second two together, positive 2b, x minus 2b. So when I take out the a, that leaves me with x minus 1. When I take out the 2b, that also leaves me with x minus 1. So my factors of the numerator are x minus 1 and a plus 2b. My denominator, difference of squares, that would be a plus 2b and a minus 2b conjugates. Now, we were multiplying, so I do not flip. I do not flip. So the factors of my numerator for the second fraction are b minus 2a and b minus 2a. That is a perfect square trinomial. And then the factors of my denominator, when I take out a 3, that leaves me with x squared minus 1, which is a difference of squares. So I get 3 times the conjugate x plus 1, x minus 1. There's a lot of different types of factoring going on in that problem. We had factor by grouping. We had difference of squares. We had a perfect square trinomial. And then we had GCF and difference of squares. So lots of different factoring methods going on. So now I'm ready to cancel a plus 2b. One of these, the a minus 2b, only cancels with one of the others. And I apologize, there's not another one, so it's not going to cancel. The x minus 1 cancels with the x minus 1. So I am left on the top with b minus 2 squared because there are 2 of them left over. And in the denominator, I have 3, a minus 2b, and an x plus 1. So that's a really big answer, but those are all the factors that are left that did not get canceled out. I hope you caught my mistake. Here again, I'm not perfect. So I did not factor that denominator correctly, which means some of our answers are not, our factors aren't going to be right. So let's try again. All right. Oops. Let's try this bad boy again. I apologize for not factoring that first problem, this part correctly. I should have taken out a 3x, which would leave me with x minus 1. I apologize. I did not take out my greatest common factor. So that gives me a 3x and an x minus 1. Now I can cancel the a plus 2b. I can cancel the x minus 1. So on the top, I am still left with b minus 2a squared. And on the bottom, I am left with the 3x and the a minus 2b. So I hope you were able to go back and catch that mistake. I did not factor this part correctly, but now I have, and I have put the correct factors in the right place and canceled everything. So I apologize for my oversight. All right, so number 13, if you notice, has a lot of stuff in it. So I have to rewrite this as a multiplication scenario. So I have b to the third plus 2b squared minus b minus 2 over b squared plus 4b plus 3. I'm going to flip this one because it follows a division symbol. So 2b squared plus 5b minus 3 all over b squared minus 4. I'm not going to flip the last problem or the last fraction because it does follow a multiplication symbol. So I only had to flip the middle problem. Now I need to factor everything. So this is 4 or more terms. So I'm going to come up here, b to the third plus 2b squared minus b minus 2. When I group, I take out a b squared, and that leaves me with b plus 2. When I group, I take out a negative 1, and that leaves me with b plus 2. So that's b squared minus 1 times b plus 2. Now, this is a difference of squares. So not only did I do factor by grouping, I'm going to have to do difference of squares as well. So when I factor that numerator, I get the conjugates b plus 1, b minus 1, and the b plus 2. Now the conjugates came from the fact that one of my factors was a difference of squares. Now, moving on to the denominator, I get b plus 3 and b plus 1 when I factor b squared plus 4b plus 3. Now, on to the second fraction. When I factor the numerator, I get 2b minus 1, and I get b plus 3. This is a difference of squares, so my conjugate factors are b plus 2, b minus 2. When I factor this numerator, I can take out a 3, and that gives me b plus 2. When I factor my last denominator, that is a difference of squares, so it's 2b plus 1 conjugate 2b minus 1. So lots of different factoring. Factor by grouping, difference of squares, trinomials, greatest common factors, lots of stuff going on. So now we need to just kind of mix and match and cancel what we can. B plus 1 cancels a B plus 1. B plus 3 cancels a B plus 3. B plus 2 cancels a B plus 2. Okay. And do you see anything else that can cancel? The b minus 1 and the 2b minus 1. The 2b minus 1 cancels the 2b minus 1. And I see nothing else that can be canceled. So across the top, I still have the b minus 1 and both of these. So 3 times b minus 1, b plus 2. You always put your monomial factor first. And then on the bottom, I have the b minus 2 and the 2b plus 1. And that would be my final answer. So if you have any questions about multiplying or dividing rational expressions, please make sure you contact me.